Hello, my name is Kelsey Farber and I'm from the Bridgeport Regional Aquaculture Science and Technology Education Center. My project is focused on absorbing high concentrations of nitrogen using biochar as a preventative measure to mitigate the dinoflagellate Karenia brevis. My goal is to develop a stable form of biochar that will absorb concentrations of nitrate in the water in an effort to limit nitrate intake in Karenia brevis. Biochar is a stable form of black carbon produced from a biomass source through either chemical or thermal conversion. I will be using thermal conversion or pyrolyzation on 4 different species of wood. Karenia brevis, the most common organism responsible for red tide blooms on the Gulf Coast, negatively impacts the environment, public health, and the economy. While red tide blooms are natural, human interference has caused them to expand due to an overflow of nutrients such as nitrogen and phosphorus, which are their main food source. An increase in the use of fertilizers and pesticides over the last century has led to an increased amount of runoff from lakes and rivers into the ocean, causing an increased concentration of these organic compounds. Reducing the concentration of nitrogen in the water will serve as a limiting factor for Karenia brevis growth. Using experimentation, different forms of biochar will be made and tested for stability and activation rates of nitrogen. Biochar is extremely absorbent and is known to capture and filter pollutants out of the water, making it a good tool to use in the manipulation of water quality. Mahogany, bamboo, oak, and birch will be used as independent variables. In the lab, the biochar will be weighed and the porosity will be calculated and recorded. Results will be compared. Each species of wood will be tested in a 300 milliliter beaker of distilled water with a concentration of 5 ppm of nitrate over a 3-day period using a vernier nitrate probe. The remaining concentration of nitrate will be recorded and compared to determine which species activates the most nitrate. After preliminary nitrate tests were conducted, results did not fit the hypothesis, so additional research was done. It was found that the wood was naturally charged with nitrate before being put in a nitrate solution. Therefore, in order to offset this, the biochar was rinsed in distilled water before being placed in a nitrate solution. The first 2 graphs on the PowerPoint show the results of nitrate testing before the biochar was rinsed, and the 3rd and 4th graphs show results after the biochar was rinsed. The first 2 graphs indicate the nitrate concentration increased over time, whereas when the biochar was rinsed, the concentration stayed at a relative constant. This shows that after being rinsed in distilled water, the biochar becomes more absorbent.